The Society of Petroleum Engineers presents SPE Tech Talk. Today's Tech Talk is brought to you by TETRA.
Welcome and thank you for joining us for this SPE Tech Talk with TETRA. I'm your host for this broadcast, Joe Sinnott, and I'm excited to dive into produced water, or at least to dive into today's episode, exploring how advanced desalination technologies are revolutionizing the management of produced water in the oil and gas industry. Our discussion will highlight the urgent need for sustainable water solutions driven by increasing produced water volumes, regulatory pressures, and environmental concerns such as drought and seismicity in disposal wells. We are joined today by our friends at TETRA to explore how innovative treatment processes can convert produced water, a challenging waste stream with highly variable chemistry, into a valuable resource suitable for beneficial reuse, including aquifer recharge, irrigation, and industrial applications. And as always, this Tech Talk will showcase real-world pilot projects and commercial deployments, emphasizing the technical breakthroughs that enable high recovery rates, low energy consumption, and compliance with stringent water quality standards. That said, we want you, the audience, to play an active role in this live broadcast. So please, let us know where you are watching from, and please share your questions and opinions about today's topic in the comments section on LinkedIn or SPE Energy Stream, and our expert will respond to as many of your questions and comments as possible later in the show. Another great way to participate is by answering today's audience poll question, which is, what do you see as the biggest barrier to beneficial reuse of produced water in oil and gas operations? Is it A, regulatory requirements, B, technology limitations, C, economic factors, D, public perception, or E, something else? And if it is something else, go ahead and share your comments, what that something else is in the comments, and even for your other answers. Again, add some color. That's the beauty of these tech talks, is that you can add all the color you want, and again, make this conversation as rich and enjoyable and valuable for you as possible. All that being said, let's go ahead and get started by introducing our guest, Jon Malone, who is joining us from the Woodlands. Jon is Director of Business Development with TETRA. Jon has over 25 years of experience in the oil and gas industry and has held roles in domestic and international operations management, as well as sales and commercial management. He holds a master's in geology and earth science from Ohio University and a BS in geology and earth science from St. Francis Xavier University in Canada. With that, Jon, hello and welcome to SPE Tech Talk.
Morning, Joe. Thanks for having me.
All right. Well, it is our pleasure to have you again. Very exciting topic. So let's get started by talking about, well, I guess why we're here, right? Let's begin by talking about the urgent need for sustainable produced water solutions, Jon.
Joe, before I start, I do want to bring up the fact that some of the people that know me anyway probably don't recognize me with a mustache, but I did want to take a second. It is Movember. It's Awareness Month for men's health. So I would encourage everyone to have a look at the Movember initiative. Every time I look at myself with this mustache, I laugh, and I can tell you my wife is not happy right now. She can't look at me. But please look out for Movember and Awareness for Men's Health. Joe, the urgent need for sustainable produced water solutions. You and I were just talking about, the water problem, as it were, in oil and gas, and you being up in the Marcellus. Water for fracturing operations has been used widely, but that water comes back along with the formation water, and there's a lot of it coming at us. We call it the wall of water. And I know really at the end of the day, production from oil and gas is going to continue. And as we continue to produce these reservoirs in the unconventional space, the water cuts that are coming from the reservoirs are high, getting higher and higher. So most of us know that for every barrel of water, there's 3 to 5 barrels of water that come with the barrel of oil. So, I've thrown up a slide here for produced water in the Permian Basin. We know it's one of the most prolific basins in the world, and certainly in the U.S. But if you look at the amount of water that's produced with the oil in the Permian Basin, you're looking at 8 to 9 billion barrels per year. So that's a lot. It's split between the Delaware and the Midland Basin here. You look at the amount of water that's treated, it's a small fraction of that. The amount of water that's re-injected for enhanced oil recovery operations, you're left with, 6 or 6.5 billion barrels of water a year that could be reused, right? And we know in today's day and age, and particularly in Texas, there's water stress in our communities, specifically in drought-stricken areas. So we look at this water as a resource. I think traditionally everyone has looked at this water as a waste. They've been injecting it downhole, trying to get rid of this water in any means necessary. And I think the mindset has changed where we can look at this water in terms of an asset. And we can talk through a little bit about how we can make that happen with some technology.
Great. Well, yeah, let's continue on. Yeah, that's it. So when it comes to technology, when it comes to, sort of innovating your way to those solutions to meet the needs and to meet that potential for beneficial reuse, Jon, what are some of those innovative treatment processes that can help get us there?
So, traditionally, when we think of water desalination, 85% of the water desalination around the world, that's typically seawater desalination, is done through membrane technologies. There's other ways to desalinate the water as well, though. There's thermal distillation, there's solvent extraction, there's other ways to be able to essentially get rid of the harmful constituents within the water and to remove the salts to create a freshwater stream, right? TETRA, we've been treating water for oil field operations for well over a decade, and we've seen the complexity of this water. And we looked at it about 5 or 6 years ago and said, what is the evolution? How can we look at this water as a resource, and what should we do about it? So we went down the path of evaluating all kinds of different technologies. We currently have an operation in Arkansas where we have a thermal distillation plant, and we essentially boil water and recondense it back into a freshwater stream. And so we understood that operation and how it worked. But as we started to look at different technologies that can also do it, we went back to this idea of membrane technologies and the ability for membrane technologies to scale, to be able to treat this water, as I said, like 85% of desalination that occurs around the world. Here's the trick. This water that's coming from oil and gas is not seawater, right? And we know that. And Joe, I know you know that from your background and your career, that this water is extremely complex. It has a much different set of constituents in it. And typically the salinity is much, much higher. So the trick was, if you see on the screen here, this is really just a very crude sort of flow chart of how we've approached it with our membrane technologies. But you take raw water, you have to pre-treat it. So you have to get rid of things like oils and greases and the large organics and metals. And you need to prepare the water such that it doesn't damage the membrane technologies. And so, we said, look, let's really focus on, over this last 4 years, on doing field pilot testing and doing testing at our facility to damage these membranes and stress them as much as we could. And we've selected two membrane technologies that we can talk a little bit more about.
Great. All right. Well, before we get into that, I do want to take a quick moment here and remind our audience that we are live here. We do these tech talks for you. So please engage, ask your questions, share your comments. We'll get to as many of them as we can. But for now, I got plenty of my own questions, John. And again, you kind of set the stage there in terms of, all right, well, what are some of these breakthroughs, right? Let's talk about some of the technological advances here that are not just, again, helping kind of manage the water, but actually drive towards high recovery rates, low energy consumption. So what can you tell us about some of these technological breakthroughs, advances, if you will, John?
So typically when we think of desalination, we think of RO, reverse osmosis. So you take a water stream that, is saline, maybe has other constituents in it that are harmful that you want to get rid of. You put that water under pump pressure through a membrane. Let's say the good stuff passes through and the bad stuff stays behind on the membrane surface. That's fine for things like seawater or lower salinity type feeds. But when you get into this produced water, you can't do that with conventional methods. So you have to look at creative ways to do it. One of the ways that we've been looking at is osmotically assisted reverse osmosis, which is essentially the ability to use osmotic pressure and to balance across the membrane the salinity through the system to be able to use the salinities as a draw solution. And what does that do? That essentially, you hit on it earlier on, reduces the energy consumption. So instead of jamming with pump pressure the water through a membrane, you're now using the water itself to reduce this osmotic pressure and start to balance the water and essentially clean the water in that respect. So that's been really, really neat for us. And then, another really innovative approach that we've been looking at is vacuum membrane distillation, which is a combination of thermal. So you heat the water and then you pull that water from a vacuum into a vapor and then you recondense that vapor. So if you have two different technologies on the membrane side that are low emissions, they're low energy, and they're efficient, we've been testing a really neat solution, and it's really innovative, and it's been really excellent to see the success.
Great. Well, it is neat. It is innovative. I know it's interesting to our audience from a technological standpoint, John.
Yeah.
But the reality is, you don't just do this stuff because it kind of needs to be done. Sometimes you have to do stuff because there's regulatory reasons, right? So can you talk about some of the pressure there, at least in terms of, how are regulations impacting the need for what we're talking about? And, at the same time, what about the market? What are market trends? How is that dictating, again, the need or the desire to embrace the technologies that you're talking about here today, John?
Yeah, when we looked at that slide earlier with the amount of produced water, there's a lot of it, and we talked about it being disposed underground. That's the traditional way to dispose it, is to drill a saltwater disposal well and then inject that water downhole into the reservoir. The problem is the reservoir's pore space is starting to fill up in a lot of these areas, and sort of the reaction of the subsurface to that overpressuring is seismicity, and so we've been seeing some of that. I would say that that's been mitigated. There's been a lot of work done on, trying to mitigate that seismicity and that overpressuring. The Railroad Commission and those that provide permits for, SWDs here in Texas in particular, they've had to create some restrictions and that type of thing. So there are some regulatory pressures around disposing of this water. We talked about drought earlier. If there's a way to take the stress off of the freshwater resources that we have from our, aquifers, lakes, rivers, etc., this is a good way to do that. But we've got to be sure that we can clean the water so that when it is discharged out into the environment, it doesn't damage, doesn't create any issues in terms of toxicity and damaging our current freshwater resources. So, that's been really interesting. I think this slide really shows a little bit about some of the potential applications for that fresh water after we clean it. Agriculture is one, but we really need to be careful. And what we're seeing is the ability for these technologies to clean the water, for it to be non-harmful to the environment. And then really what's emerging right now, Joe, which is interesting, and it's really sort of consuming my reading in the morning when I wake up, is this insatiable sort of appetite for data and growing these AI centers and data centers, and then distributed power to be able to power these. They all take a lot of water. And this is a good way for us to supplement the fresh water that we need for our communities, and use an industrial water that, that can be used for these applications. So we're really at an interesting point in time here where we have the ability to do, again, to use this waste as a resource.
Great. Well, thank you for sharing that. And again, touching on, how connected all of this is, right? None of this happens in a vacuum, although I think you did just talk about some sort of vacuum technology, right? Was it vacuum membrane distillation or something? But none of this happens in a vacuum, right? It has impacts, in, various industries. It goes, beyond the confines of just the oil and gas industry. That being said, within the oil and gas industry, can you talk about collaboration? Can you talk about the connections that are necessary to move things forward, to unlock value, to reduce risk, Jon?
Yeah, no, excellent point. Oil and gas operators, as we talked about, there's some issues with seismicity and managing this water, but hey, look, they're wanting to collaborate with technology providers like TETRA. Let's figure out a solution. Let's do as much testing, piloting that we need to do in order to get comfortable with the reliability of the technology, how robust it is, ultimately to be able to, use this water and discharge it for other applications. And the regulatory bodies need that data. They need that assurance that these systems are going to be effective and reliable. And so this collaboration with the technology and industry and the operators, as well as academia. So you look at some of these consortiums, research consortiums that have been stood up over the last several years through Texas Tech in Texas with Shane Walker and his team, and then Mike Hightower and Zach Stoll in New Mexico at NMSU. It's really been a great collaboration between the industry and academia to really show some of the advancement and the potential of these technologies.
Great. All right. Well, thank you for sharing those insights. It's probably a good time here. We're moving along, but I do want to revisit a question that we posed to our audience earlier, Jon. I've been asking you questions here over the last couple of minutes, but at the outset of this, we asked the audience, hey, what do you see as the biggest barrier to beneficial reuse of produced water in oil and gas operations? Regulatory requirements, technology limitations, economic factors, public perception, et cetera. It seemed like D was the majority of our answers today, at least. So curious your thoughts. What would you have expected to see? What are you seeing? Talk a little bit about, maybe your answer to that question, Jon, and your response to those who responded to.
So what I'm hearing is that people think this is too expensive, right? And so what's interesting, we talked about disposing, the traditional way of disposing this water, and the disposal cost, the cost of disposing that water. You have to take it from the well, you've got to bring it to an SWD well, whether you pipe it, truck it, whatever, you have to maintain that SWD well, you have to drill it, all these things. So there's a certain cents per barrel that costs in order to do that. And then employing these technologies as an alternative to treating this water has been expensive. But what we're seeing is a convergence. So we're seeing the disposal costs increase with the amount, maybe some restrictions around the capacities in these disposal wells. And then if you look at the technologies and the improvement of the technologies, the scalability of these technologies, the cost to treat is coming down. So essentially, we're starting to see a convergence of the costs of disposing in traditional ways, and now the ability to use technology to clean it. So it's an exciting time. Being involved on day to day and watching this technology evolve, there's certainly runway for it to improve even more. So I understand people's economic concerns, and that's been the challenge. That's been the fun part, is really working to determine how we can make this a cost-effective solution.
Great. Well, I think you just used challenge and fun as basically they're the same thing, right? If I heard you correctly. So let's play with that. Let's have some fun here. So can we talk more about what are the biggest challenges then? So when it comes to, treating produced water and ultimately getting it to, a position where you can use it for beneficial reuse, what are those challenges slash fun opportunities, Jon?
Yes, we talked about the water itself, this produced water, and the constituents that are in there that are could potentially be very harmful if they're discharged out into the environment. So we look at things like organics, we look at things like metals and heavy metals. On the organic side, people hear about things like volatile organic carbons, semi-volatile organic carbons, and just even the oils and greases and these types of things. And so, yeah, it's a challenge. It is a challenge, but what's really encouraging is all the work that we talked about that the community and the industry has been doing around trying to treat it and remove these harmful constituents. It's been successful. And so extremely encouraging there. I would say after one of the challenges through a lot of these treatment trains, whether it be a thermal system, a membrane system, or others, there's always some post-treatment that needs to be done at the end. And what seems to be hanging around, depending on the technology, is ammonia and boron. And these are two things that if we don't control them, they can be toxic to the environment. But what's interesting, if you think of ammonia, if you had a certain level of ammonia and you use that water that had ammonia in it, in agriculture, we know ammonia is used. So, there's ways for us to be thinking about things like ammonia and not having to put the expense into removing ammonia when it could actually be a benefit, right? So a lot of this work is being done towards that. Hopefully that's helpful to kind of understand some of the challenges and some of the constituents in the water. It's not as simple as treating seawater as an example.
Yeah, and the good thing is, again, for our audience here, Jon, we don't like simple, right? These are tech talks here, so people like the challenge, and I think like yourself, they like the fun here. So that being said, for the benefit of our audience, for the benefit of myself, you gave some color there. You kind of stepped through the evolution of some of these approaches, but how would you summarize the difference between, call it old school, traditional water treatment processes and the advanced desalination technologies? Again, you kind of gave some color earlier, but
yeah.
What's the takeaway for me to be able to go and pretend like I know what I'm talking about when I hop off this tech talk?
I think it's efficiency. Really, it's being able to take traditional processes and improve them so that from an energy standpoint, they're way more efficient. I talked about some of this pump pressure and just the energy used for that type of solution on a membrane solution. But even on a thermal solution where you're essentially boiling water and recondensing it, they're very energy intensive. On a thermal process, you can recapture that heat and reuse it into the system. And so some of those, technologies around, heat capture and recovery and things like that have improved tremendously. And so that's really the difference, I think, is just this continual advancement in the efficiency of the traditional practices. It's there's more room, there's more runway for it. I think as we continue to hit these fun challenges, we can take them head on and improve them. Joe, you talked about drilling in your previous life and directional drilling. At one point, we never would have thought some of these rotary steerable tools and the drilling technologies would ever be where they're at today. So we just need to keep pushing.
Sure. I mean, we're privileged to be part of a fun industry, right? We get to push, we get to innovate, we get to have fun. But Jon, at the end of the day, I know there are plenty of operators out there who have whole compliance departments, and they're sitting there thinking, wow, that's great. You're having fun. You're doing all these things. But when it comes to actually, making sure that we're adhering to water quality standards, if we're going to go down the path of beneficial reuse, how do you give them some sort of assurance? How do you make sure that those compliance folks there are not, losing sleep at night?
Yeah, no, it's a good question. When you think of it in terms of the water itself, testing, right? Having the ability to test the water real time using some of the technologies and testing practices that are out there today to give the assurance that as this water is being treated and discharged, that it is safe. And those technologies are there, and they're used in other industries. And I would say, look, the reliability of the systems themselves, right? So if you are relying on a water treatment system to provide you water, clean the water, whatever the end use application is, it needs to be reliable and robust. So if I'm talking to a compliance customer of mine or on their legal department, these are the things that we talk about. TETRA has been around for 40 plus years. Our background is in chemistry. We understand brines and waters. When I have a conversation with our customers, I make sure I bring that up for obvious reasons, that we're reputable. We've been around a long time for a reason. And, you know, we are one of the many groups in the industry that can take this challenge head on and provide this resource.
Great. All right. Well, I don't want to say I'm going to play skeptic here, Jon, but you know, this all sounds good, but in practice, when we're talking about, you know, the membrane-based desalination, brine concentration technologies, all this type of stuff, how do they actually, you know, work together in practice? What does that actually look like for a layman who's saying, all right, how does this all fit together?
So in terms of, you're talking about in terms of collaborating for technologies?
Well, I mean, not so much even on the collaboration, just on the actual desalination, the brine concentration technologies, you know, when you put them in place, maybe I should put it that way, you know, how do you actually go from, hey, this all sounds good to, all right, like what are the actual, you know, A to B, B to C, C to D that actually has to happen for these technologies to work?
Yeah. Look, we have been testing and piloting these systems for 4 or 5 years. So we talked about the challenge, the fun challenge of trying to get these systems to work. And, you know, people want to see things work in person. You know, it's great to do things in a lab and behind the curtain and that type of thing. But, you know, where we've really seen success and we've been able to really challenge ourselves internally on whether we have a good solution is piloting. And so we've, you know, end of 2022, we did a field pilot. We're currently doing a field pilot right now, partnering with an operator to do so. And as we understand the reliability and we put this together, we're designing systems that are much larger, that emulate some of these larger systems for seawater and other desalination plants around the world. So, you know, it's getting that assurance from the bench top all the way to the commercial scale that we need it to be today. And that's been really rewarding. Challenging and rewarding, and I'll use the word fun again because we're really enjoying watching this thing move forward, and it has legs, so it's really good to see.
Great. Well, I'm glad you're having fun, but we do have questions flowing in, multiple questions that talk about economics, right? So, you know, as we draw to conclusion here, I'd be remiss not to, you know, bring in that question, elephant in the room, right? You know, does this make financial sense? What are the economics and the economic incentives, if you will, for oil and gas companies to actually invest in beneficial reuse?
Yeah, no, interesting point. So we talked about the cost of treating the water. It is more than disposing of the water in the main areas today, but there are areas outside of the core disposal areas where it's more expensive and actually the treatment is less, right? So we talked about the economics around that. But what's really interesting is we can monetize this water. So if you look at in terms of taking fresh water for, we talked about AI, data centers, distributed power operations, cooling towers, things like that. Those developers are buying the water. They're buying fresh water today. So this is a way for us to treat this water, and then we can resell that water. So from an economic standpoint, we get a balance. The other really neat thing that we're seeing, and we've been doing a lot of testing on here at TETRA, is removing some minerals, some critical minerals in some cases, and then just valuable minerals. Things like lithium everyone talks about, things like magnesium, things like iodine, all things that are commodities, and we have the ability to extract those economically. And those also provide another revenue stream to offset the cost of treating this water and actually doing that extraction. So as these technologies are advancing, we're really seeing that balance, and that it's making the economic equation a lot easier to solve.
Got it. All right. Well, thank you for, sounds like maybe giving us a bit of a glimpse into your crystal ball there and what the future holds. I think everybody, honestly, Jon, you talk about critical minerals and AI. We could probably spend another hour conversing about that. And certainly the questions coming in suggest that. But unfortunately, we don't have that hour. So I want to turn it back to you for a bit of a closing statement. Anything that we didn't cover, or anything you want to emphasize, anything that you want our audience walking away with regarding water treatment, potential beneficial reuse, anything that we covered today, Jon. So final words for you here.
And again, Joe, thanks for hosting this, and maybe we'll do it again and talk more about mineral recovery and the ability to provide this water for other industrial applications. But I would just say, look, we are at a point right now that we are comfortable that we can treat this water. The technology works. When we look at scaling this technology up to meet the challenge and the volumes that we have, there's a pathway for us to do that, and it's real. It emulates some of these other large-scale plants that we see around the world. So this is a real solution. I think we still need to do some work with the regulatory bodies to get them comfortable that we are reputable, that we are able to treat this water, repeat, have a reliable solution. And so we're excited. We're working with those partners and those stakeholders today. So really appreciate the time today.
Great. Oh, thank you. And for our audience, if they want to continue the conversation or learn more about some of these topics, Jon, what is the best way for them to go ahead and get a hold of you?
Yeah, look, it looks like I've got a lot of ways to get a hold of me here on the screen. So please don't hesitate to reach out. As you can tell, I like talking about this stuff. It's exciting times. We have a real solution. This is transformative for the oil and gas industry and also our communities where we can provide this freshwater stream. So please reach out. Don't hesitate. I'd love to answer some questions. Looks like there's quite a few that have come in, and can't get to them all today, but I'd love to take a stab at getting back to you guys.
Great. All right. Well, to the audience, you heard Jon. So reach out, take advantage. Thank you all to our audience who asked questions today. Thank you, Jon, of course, for joining us on this mid-Movember day here to talk about the future of produced water desalination. Special thanks, of course, to TETRA for making today's broadcast possible. And if you or someone would like to watch a replay of this broadcast, you can do so by heading over to the SPE Energy Stream, the industry's digital pulse. Visit streaming.spe.org. I'm your host, Joe Sinnott. Join us again next time right here on SPE Tech Talk.
Don't miss a moment of any of the great SPE LinkedIn Live events. From the event page, click Attend and Add to Calendar for notification reminders when an SPE LinkedIn Live event is ready to begin. SPE Lives, Tech Talks, Get to Know series, and more. Remember, click Attend on LinkedIn.
In a rapidly evolving energy industry, you need to stay ahead of the curve with relevant content available when and where it's convenient for you. You need the upgraded SPE Energy Stream, the global platform for high-quality content with the energy industry. Fuel your energy career with Energy Stream's sleek new look and easy access to top-quality technical solutions, insights and innovations, trending topics, thought leadership, market outlooks, and education. From original programs to exclusive SPE event highlights, this exciting, easy-to-navigate platform features insightful content delivered live and on demand. Explore insights from industry thought leaders. Then save the videos that interest you and watch them at your convenience. Be at the forefront of energy knowledge and explore the newly updated SPE Energy Stream now.
The Society of Petroleum Engineers presents SPE Tech Talk. Today's Tech Talk is brought to you by TETRA.